All right, we're going to use a test for concavity to solve this problem, which says consider the function f of x below. Over what intervals is the function concave up? Give your answer in interval notation. Okay, so we need to determine the points at which the second derivative is greater than 0. So let's go ahead and figure out what our intervals are going to be. So to figure out what the intervals are going to be, we first need to take the first derivative of this function. And then we'll take the second derivative of this function. And we'll go ahead and do 28 times 3 over here. So this is 84x squared minus 8. And that's actually the second derivative. So either the second derivative is 0 when concavity changes or undefined. Since this is a quadratic, it cannot be undefined. So we're going to go ahead and go into our second phase here and set our second derivative equal to 0 to determine intervals to test. So probably gonna have to reduce a couple of times here, but let's give this a shot. Okay, so if I take the square root of both sides, I can determine intervals to test. So x can be either positive square root of 2 over 21, or x can also be negative square root of 2 over 21. And so we've got intervals that we can check, and we're going to check the signs inside those intervals. So this is going to be from minus infinity to negative 2. Oops. Negative square root of 2 over 21. And then we're going to test the interval from minus root 2 over 21 to root 2 over 21. And then the final one will be from root 2 over 21 to infinity. Okay, so I think a value in this interval, we could safely use x equal to negative 1. We could use 0 here, and over here we'll use x equal 1. I'm going to go ahead and erase our computation, which we don't need anymore. And let's go ahead and plug in our value for the second derivative. So f prime, double prime rather, of negative 1. That's going to be 84 times negative 1 squared minus 8. And without having to do any of the math, I think we can see that that's going to be greater than 0. So it's going to be concave up on that interval. And then if I plug in a 0, 84 times 0 squared minus 8, that's going to be less than 0. So it's going to be concave down on that interval. And then let's check the last interval. And our test point is going to be a 1. So 84 times 1 squared minus 8. Again, that's going to be greater than 0. So this is going to be concave up. So it's going to be concave up on this interval and on this interval, which is what we're looking for.